Okay, so yes, someone just asked me regarding gamma gamma matrix, right? And I am explaining this thing. So basically, suppose in a compound nuclear reaction, suppose very simple scenario, two nuclei are populated, X and Y. These are the two nuclei, X and Y. Now, these are the gamma rays of these two nuclei. For nuclei Y, gamma A, gamma B, gamma E. And these are the excitation energies. Similarly, for nucleus X, these are the three energies. Good. Now, I am asking a condition, I am putting a condition, you can say. Suppose in the detector, now you can say that compound nuclear reaction, two nuclei. Now I am going to do a coincidence measurement. Coincidence means I am catching one gamma ray and then I am trying to figure out how many other gamma rays are there in coincidence with this one. Okay, so how many detectors do I need? Minimum 2 detectors. Minimum 2. The more the better. So let me now put the condition that I have caught this gamma ray, gamma A. Okay, so I have caught this gamma ray, gamma A, and I am asking the condition that in coincidence with gamma A, what other gamma rays are there? So here I am putting a condition, show me the spectra for gamma rays in coincidence with gamma A. I am not talking about the electronic circuit here. I have talked about it previously. Tomorrow again I will show it to you in a detailed way. But right now I am talking about the physics output. That means if I do a condition like that, what do I observe and why do I observe what I observe? Okay, so see, the first thing to note that gamma A energy is lower than gamma B is lower than gamma C. Let us consider it like that. So in this case, if I observe gamma A, here what other gamma rays are there? In this nucleus, gamma B and gamma E. So they will be coincident with it. Given the condition that the lifetime of these energy levels are very less. This is important. If the lifetime of this one is very large, then they will be coming in different times and they will not be coincident. Okay, so there is an inherent approximation that the lifetime of these levels are very less compared to the coincident time window. Understood? Okay, so now what do I observe? You see, this is what I am observing. This is the counts and this is the energy axis. So I am observing the peak due to gamma B at, you see, gamma B, the energy excitation level, this one corresponds to EB. So this is the gamma ray energy EB corresponding, and this is gamma E, EE, right? Now here I am not observing anything from X nuclei. Why? Now you see, we are living in seconds, in hours, in days, right? But these nuclei, they will be produced in a matter of nanoseconds or even less. So maybe the coincident time window is 10 nanoseconds. Okay, and this nucleus is produced say after 120 nanoseconds after the production of this nucleus. So after the production of this nucleus, say 120 nanoseconds later on, this nucleus is produced. So tell me, will the gamma rays of this nuclei be coincident with them given the coincident time window of 10 nanoseconds? No. That's why you will not observe them over here. You will observe all the gamma rays within the coincident time window of 10 nanoseconds. Ask me now. 10 nanosecond, 10 nanosecond, even 11 nanosecond you will not observe. So if this nucleus is born after 12 nanoseconds of its production, so you will not observe it. You can think of it like that. Okay, so this is what I am observing. Good. Now let me do this map in a different way over here. This is known as coincidence matrix. You see this one. This is coincidence matrix. So there are two axes. This is x-axis, this is y-axis. Both are identical. Here we have got increasing energy in this way. Here again increasing energy. Now I have shown you, instead of energies, I have shown you the corresponding gamma energies. So suppose here this is gamma A, EA, EB and EE corresponding. Now see what you observe. So which gamma rays are coincident with gamma A? Look into the structure. Gamma B and gamma E. So in this structure, in this matrix, corresponding only to gamma B and gamma E, you will see points. Same for gamma B, these two gamma rays are coincident with it. So you will observe points over here and here. For gamma E, that means this one, you will see like this. Okay. So here is the points. So this is a coincident matrix. How it looks like. This will be, there will be nothing over here, nothing over here, nothing over here, because you have already caught the same gamma ray. How can you observe it again? Now let me draw the other gamma rays as well. Suppose this gamma D is over here. This is gamma D. This is gamma D. You draw it in your copies as well. Okay, try to draw this. Or maybe I will draw this bigger. Okay, so let me draw this. This is better. Okay, so this was initially gamma A, this is gamma B, and this was gamma C, right? Let me draw it over here as well. Gamma A, gamma B and gamma E, not C, it will be E. And here we have D, C and F. So the energies, suppose they are like this, gamma D, gamma C and gamma F. So gamma C, gamma D and gamma F. So tell me, what will you observe? First, see this gamma A. Gamma A, which one will be coincident with it? Gamma B will be coincident with gamma A and gamma E. So you will see points over here. For gamma B, you will see points corresponding to gamma A.
Gamma D হবে
কোনটা?
স্যার এই
নিচেরটা বা একসাথে নিচে একদম আমাদের
Yes.
D
Gamma
এর
D,
উপরে একটা C
gamma C. Good. Okay, so gamma B corresponding what gamma rays are there? Gamma A and gamma E. Gamma E. Okay. So here, next, gamma E. It will be gamma A and gamma B over here. Okay. Next, what about gamma D?
gamma C gamma F
Gamma C and gamma F. What about gamma C here?
gamma T gamma F
Again, gamma D and gamma F. And lastly, gamma F corresponding to gamma D
gamma C
and gamma C. So, given that these two nuclei are produced, very simple scenario. So, this is the gamma gamma coincidence matrix. Okay, so this is how it will look like. Now, here I have not considered any accidental coincidence. That means some spurious gamma rays entering into the picture. All correspond to real coincidence. So, in the experiment, here, if you see some entry somewhere else, say here or here or here, this will be mainly due to accidental coincidences. So keep this in mind. Okay? Any more questions?
সে অ্যাক্সিডেন্টাল কোইন্সিডেন্সটা কোথা থেকে হচ্ছে সেই নিউক্লিয়াস
Maybe some other nucleus is also produced that I am unaware of. Maybe it has got energies which is close in energy to gamma A or gamma B that I am unaware of. It is possible. Okay? So I have to figure it out, that secondary part. Yes. Yes. There is a, yeah, you can say like that. So very basic example of gamma-gamma coincidence matrix considering only two nuclei. Okay. So I might ask you in this examination. So what? How can I ask? I can ask you, suppose three nuclei are formed. Consider the scenario, each of the nuclei has three gamma energies. Now draw the corresponding gamma-gamma matrix.
9 cross 9 matrix.
Yes, 9 cross 9 matrix, you can say. Okay, so you are asking me that how the coincidence is done. You see, I have told you we have got two detectors. Minimum we need two detectors, right? So suppose this is detector 1 and this is detector 2. And in these detectors you will observe a lot of spectra, right? Both of them. Now this is singles. Singles means whatever is there you observe in the spectrum. In the two detectors you are observing. Next, you are putting a gate on the gamma A. Say for example this one. This one. So what you do, say you take detector 1, this is gamma A over here. Okay. So you put a condition that this is the narrow channel, okay, and then whatever count is there in this narrow channel, show me the corresponding spectrum in detector 2. If you will do that, then you will see a coincidence spectrum. In detector 2, previously you are seeing single spectrum. Now you will see this is gamma A, right? Now you will see what? Only gamma B and gamma C. So now you will see only this. See? Why? Because only gamma B and gamma E, they are coincident with gamma A. So the moment you do this condition, this spectrum cleans up. There were so many things, they just cleaned up. And you will see a cleaner spectrum with only two peaks. Gamma B and gamma E.
So gate was gamma A.
This is gate.
What a gamma A energy?
Yes, putting energy gate on gamma A energy.
So gamma A energy तो gamma B या gamma A से कम.
Right.
और gate का energy तो कम.
আমি ওই জন্য কম নিয়েছি, দেখো এখানে গামা বি গামা ই করেসপন্ডিং
और gate का मध्य gamma E पास करते gamma B या gamma E.
No, gate gamma B is over here, gamma E is over here. I am not putting a gate on them. I am putting a gate on gamma E only. Think of it like that. I am putting a condition using energy. So here I am choosing this energy as my gating condition. So this is single spectrum. From singles I am getting double spectrum.
Example energy तो gamma B minus gamma E.
Which one?
वही जो gamma B या gamma E का जेटा 5 detector टू है.
Yes.
वो जो energy था वो तो gamma B minus gamma E energy था.
No, this will be EEB and this will be EE. See the spectrum? This will be EB. This thing is EB. This thing is EE. Now you tell me. Now suppose I am having three detectors. Detector 1, detector 2, detector 3. D1, D2, D3. Okay? In detector, they have all got some spectrum. Okay, some spectrum. Now I am putting a condition in gamma A over here. In gamma A, detector 1. And as a result, I am observing something in detector 2. What do I observe?
Gamma B
or
and gamma E.
Gamma E. Their counter will be there as well. Next, I am putting a gate on gamma B here. Now tell me what will I observe in detector 3?
শুধু gamma E.
Gamma E.
Right. Here I will see only gamma 3. Okay. Or EE. But suppose, now tell me, suppose in this spectrum, if I observe some other gamma ray as well. Suppose in this spectrum, I am observing gamma A, gamma B, and some other spectrum, some other gamma ray. Unknown, say gamma X. What will it mean?
Accidental gamma ray, coincident
That
object.
means some other gamma ray was there as well. That gamma ray can be something above this as well.
Upper excitatory.
Gamma X. This is how we do gamma ray spectroscopy. That means we try to find out information about more and more high energy levels, right? Now, if this is true, then I will also observe it over here as well, gamma X. Okay. Now see, this is an example of triple coincidence matrix. Triple coincidence matrix or gamma 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 matrix, because here you are doing
Gamma gamma.
okay gamma gamma gamma. You can do like that. Basically, what I can say is that when I am putting a condition like this, basically you can say this is gamma gamma or gamma 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 plus matrix as well. Because if I see this thing, this is the result of gamma gamma matrix. And if I do a triple coincidence, then the next time I will see the result of 3 gamma coincidences. Okay. So gamma gamma matrix and gamma 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 matrix. So we have covered these 2 topics. So in gamma gamma matrix we have got this gamma as well as gamma, and in gamma gamma matrix, triple gamma, basically we have got a cube. Okay. Gamma gamma gamma. So this is also called cube. And this is just a 2-dimensional matrix. In gamma ray spectroscopy, suppose I am using more than 100 detectors, then sometimes we can do 6 coincidences, 6 hypercube, you can say. Gamma, 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 gamma. Even 8. Next day I will show you how the calculation involves. Okay.